Dawn breaks gray and unforgiving over the Sicilian coast. July 10th, 1943. The Mediterranean rolls in long, predictable swells, but there's nothing predictable about what rides them. A gray-green line of landing craft punches through the surf, diesel breath mixing with salt spray, the rattle of small arms stitching the morning air. Inside LCVP 1442, 36 men crouch in steel and plywood, their rifles slick with spray, their stomachs tight with the knowledge that in 60 seconds, everything changes. The coxswain's hand finds the lever. A 19-year-old kid from Louisiana bayou country, reading these Italian waves like he once read the channels between cypress stumps. His palm closes. The mechanism engages with a metallic clank that cuts through engine noise and gunfire. The bow ramp drops like a drawbridge, and suddenly the sea becomes a hallway. Water rushes in. Men surge forward. Tracers comb the foam as boots splash into the shallows, and 36 soldiers transform from passengers into an advancing line. But the camera stays on the hinge, that smallest part with the largest consequence. The simple mechanism that just turned salt water into an address, that converted the last 100 yards of ocean into the first 100 yards of Europe. The sound it makes, that wet, metallic thunk, will echo in 1,000 after-action reports, in 10,000 letters home, in the nightmares and daydreams of a generation. It's the sound of arrival itself, engineered and mass-produced, delivered on schedule under fire. This is the story of how America didn't just build a boat. It industrialized invasion. The claim demands stating clearly, by 1943, the United States had weaponized the concept of arrival itself, not just fielding vessels, but perfecting a method, design married to doctrine, married to factories, that could turn any coastline into a schedulable address. The Higgins Boats' bow-ramped LCVP collapsed the fundamental advantage that had protected defenders since warfare began, the assumption that getting there would always be harder than staying put. Minutes and meters became predictable throughput. Amphibious assault shifted from desperate heroics to timed delivery, as reliable as a mail route and twice as unstoppable. The arithmetic was brutal in its simplicity. A single LCVP could land 36 men in 30 seconds, then return for more. Multiply that by hundreds of boats, sequence the waves by minute, and suddenly the defender's equation breaks down. Kill rates cannot outrun arrival rates when every passing minute deposits another rifle squad. Then another. Then another. The Axis powers would learn this math the hard way, watching their beach defenses dissolve under a tide that ran on production schedules rather than luck. But every revolution begins with a single insight, often in the most unlikely place. The story of this particular revolution starts in the Louisiana bayou, where a boat builder named Jackson Higgins was solving a completely different problem. The Eureka workboat had been born in Gulf marshes, designed to carry hunters and trappers through water too shallow for propellers, too thick with reeds for conventional hulls. Higgins gave it a shallow draft, hard Chinese that could ride over obstacles, and a protected propeller that wouldn't tangle in vegetation. It was a swamp problem with a swamp solution: how to cross mud and reeds without getting stuck. Military observers watching. Marines struggle with conventional landing craft in 1938 exercises saw something else entirely. They watched men climbing over high sides under fire, watched boats broaching in surf, watched the deadly bottleneck of disembarkation turn assault waves into target practice. Then someone mentioned the Japanese Daihatsu, their beaching craft with a bow ramp that dropped like a gangplank, spilling troops directly onto sand. Higgins redrew his bow. The marsh boat's DNA remained. Shallow draft, hard Chinese, protected prop, but now it carried something revolutionary: instant offload capability. The specifications tell the story in cold numbers: 36 feet of length, 12 knots when loaded, 3 feet of draft, steel ramp operated by cable winch, plywood sides for lightness and field repair. What had begun as a solution for crossing Louisiana swampland became the universal answer to crossing the last 100 yards of any war. The prototype tests were promising. The production requirements were staggering. By 1941, Higgins Industries had exploded from a neighborhood boatyard into a constellation of plants stretched along New Orleans' Industrial Canal and the shores of Lake Pontchartrain. The transformation defied every assumption about traditional shipbuilding. Where established yards built ships like sculptures, each one crafted, fitted, finished by master shipwrights, Higgins built boats like Ford built cars. Standardized jigs held hull sections in perfect alignment. Pre-cut part kits eliminated the measuring and cutting that ate up production time. Shift choreography turned assembly into rhythm. One team laid the keel, another fitted the sides, a third installed the engine, a fourth mounted the ramp mechanism. At peak production, finished LCVPs rolled off the ways every few minutes, their gray hulls still wet with primer as crane operators swung them toward the shipping channels. The workforce was as revolutionary as the process. Cajun carpenters who understood wood and water worked alongside women welders learning to join steel plate with acetylene precision. Black foremen, promoted not by tradition but by throughput skill, optimized jig changes and timing sequences. The old social hierarchies of the shipyard dissolved under the pressure of production quotas. When the Navy needed 20,000 boats and the calendar allowed 18 months to build them, efficiency mattered more than etiquette. The math was relentless. Every hour saved in construction was 36 more men who could reach a beach 30 minutes sooner. Every dollar trimmed from unit cost was another boat that could join the fleet. As production scaled up, costs fell and delivery tempo rose. The economics of mass production met the logistics of global war, and the marriage produced a tide of gray hulls that would soon darken harbors from Scotland to Australia. But first, they had to learn how to use them. North Africa in November 1942 was where theory met reality, and reality proved to be a harsh instructor. Operation Torch scattered American and British forces across hundreds of miles of Moroccan and Algerian coastline, and the early hours revealed just how much they had to learn about turning boats into beachheads. Night navigation proved treacherous when landmarks disappeared in darkness. Surf reading became life-or-death skill when coxswains had to judge wave patterns they'd never seen before. Beach control collapsed into chaos when landing craft arrived at the wrong locations, at the wrong times, with the wrong loads. Radio communications fought losing battles against salt spray and engine noise. Some boats grounded too far out, forcing men to wade through chest-deep water under fire. Others pushed too far inland and couldn't retract when the tide turned. The LCVP itself performed exactly as designed. The ramp dropped, the men disembarked, the boat retracted for the next load. But the system around it, the coordination, the timing, the communication, struggled to keep pace with the elegant simplicity of the basic concept. The learning curve was steep and expensive, measured in lives rather than dollars. Beachmasters with Aldous lamps learned to signal boat waves through surf zones. Colored smoke began marking designated landing areas. Beaches received numbers and sectors, turning anonymous coastline into postal addresses. Pre-staged cargo nets hanging from transport ships eliminated the confusion of individual loading. Boat lanes, like highway traffic patterns, prevented collisions in the approach zones. By early 1943, the rough edges had been smoothed into doctrine. Amphibious assault was transforming from desperate adventure into logistics under fire. Repeatable, improvable, and increasingly predictable. The torch landings had been messy but decisive. The next operation would prove that the lessons had been learned. Sicily, in July 1943, multiplied the torch template across a front that stretched for 100 miles. Operation Husky was Torch's older, wiser brother. Still dangerous, but no longer uncertain about its methods. LSDs and LSTs, the floating garages of amphibious warfare, opened their steel mouths in the pre-dawn darkness. LCVPs poured out in sequenced waves, each one a precision delivery scheduled to the minute. Gela, Licata, Scoglitti, beaches that had been anonymous stretches of Italian sand, became industrial addresses. Each ramp drop functioned like a miniature factory shipment. Rifles and medics in the first wave, then jeeps and radio equipment, then 37mm guns and ammunition sleds, then water cans and field kitchens and all the mundane necessities that turned invasion into occupation. The Axis defenders found themselves facing an equation they couldn't solve. Individual LCVPs could be sunk, individual waves could be disrupted, but the mathematical foundation of the assault was beyond their capacity to break. Kill rates, no matter how impressive, could not outrun arrival rates when every minute brought another boat, another ramp drop, another 36 men adding to the accumulating pressure on their positions. German and Italian gunners, trained in the mathematics of traditional warfare, discovered that amphibious logistics operated by different rules. In conventional battle, attacking forces diminished over time. Casualties, exhaustion, supply problems gradually weakened the assault. But the LCVP system actually grew stronger as it continued. Each successful landing cleared more beach space for subsequent waves. Each established foothold provided covering fire for the next group of boats. The beachhead expanded, not despite resistance, but through it, like water finding every crack in a dam. By evening on July 10th, the principle had been proven beyond argument. Coastlines were no longer barriers. They were simply another type of terrain, to be crossed with the right equipment and sufficient logistics. The age of fortress islands was ending, but every system has its limits, and in November 1943, the Central Pacific provided a brutal education in where those limits lay. Betio Island at Tarawa Atoll presented challenges that no amount of Louisiana factory production could solve. The coral reef surrounding the island created a natural barrier that maps and intelligence reports had inadequately described. When the assault waves reached the reef line, low tide stranded the LCVPs in water too shallow for their 3-foot draft, but too deep for men to wade efficiently. Marines found themselves chest-deep in lagoon water, advancing across hundreds of yards of coral under interlocking machine gun fire. The ramp mechanism that had worked so perfectly on sand beaches became irrelevant when the boats couldn't reach the beach at all. Some coxswains, desperate to deliver their passengers, drove their LCVPs directly onto coral heads, grinding their hulls to splinters in the process. The system flexed under this new pressure, adapting with the speed that only desperation can provide. Tracked landing vehicles, LVTs that could climb reefs where LCVPs couldn't, moved from experimental equipment to frontline necessity. Hydrographic intelligence, previously an afterthought in mission planning, became as crucial as weather reports. Tide tables and reef charts joined the essential documents that determined assault timing. Most importantly, the human element of the system proved its resilience. Coxswains learned ramp discipline under fire, keeping their boats stable while Marines disembarked into hostile water. Cross-loading techniques distributed essential personnel and equipment across multiple boats, ensuring that no single loss could cripple an entire mission. Casualty backhaul procedures, practiced in peaceful waters, proved their worth when wounded men needed immediate evacuation. The ordeal at Tarawa cost lives, but it preserved the system. The method survived its hardest test, not because it was perfect, but because it was adaptable. Logistics, it turned out, learned faster than fortifications when lives depended on its clock. Behind every system, no matter how mechanical it appears, are the people who make it work. The Higgins Boats story is ultimately a human story. told in the voices of those who built them, crewed them, and depended on them when everything else failed. There was the 19-year-old coxswain from Plaquemines, Parrish, who learned to read rip currents and tide lines like his grandfather had read muskrat runs through the marsh. His hands on the boat's wheel carried generations of Louisiana water knowledge, applied now to beaches from Normandy to Okinawa. In letters home, he described the weight of responsibility. 36 lives riding behind him, 36 families trusting his judgment of waves and timing and the exact moment to drop that ramp. In New Orleans, a welder named Marie Thibodeau taught her teenage daughter to run beads on scrap metal between shifts, the acetylene torch hissing blue flame in their backyard workshop. The daughter would later write about the smell of hot steel and burning flux, about her mother's steady hands guiding white-hot metal into perfect joints, about the pride of knowing that every boat they touched would carry American boys safely to shore and home again. James Washington, promoted from assembly worker to production supervisor not because of his education, but because he could visualize the entire hull construction process and optimize it for speed, found ways to squeeze one more boat per day from each jig line. His innovations in workflow timing and tool organization were studied and copied throughout the Higgins network. In a segregated society, the factory floor proved that talent and efficiency recognized no color lines. When the mission demanded results, Red Cross nurse named Helen Morrison stepped off LCVP 7712 at Anzio with nothing but a canvas medical kit and 20 years of small-town hospital experience. She would later describe the strange confidence that came from knowing the boat behind her could return in 40 minutes with supplies, reinforcements, or evacuation if needed. The LCVP wasn't just transportation, it was a promise that America would keep coming back. These individual stories accumulated into something larger, a moral counterpoint to the industrial statistics. The broadened shop floor that built the boats had also built a broader definition of who could serve, who could lead, who could be trusted with the essential work of victory. The arithmetic of inclusion proved as decisive as the arithmetic of production. Letters from the front lines carried sensory memories that outlasted medals and commendations. The resin stink of new plywood in tropical heat, the diesel itch that got into clothing and skin and seemed to take weeks to wash out, the particular sound of waves slapping against a loaded hull, the metallic screech of the ramp cables under tension, and always that wet thunk of the ramp hitting sand or shingle or coral, the sound that meant the boat ride was over and the real work was about to begin. By 1945, the numbers told a story that no enemy could argue with. A single American division landing required thousands of individual ramp drops, sequenced by minute and coordinated across miles of coastline. Only a republic of factories could keep that promise. Only a system that treated every beach like a loading dock could maintain that tempo. The Axis powers had built magnificent ships, sleek destroyers, powerful battleships, submarines that could strike across entire ocean basins. But they had never solved the fundamental problem of turning boats into boots on ground. Their doctrine remained locked in the assumptions of traditional naval warfare, where ships fought ships and armies fought armies, and the boundary between sea and land remained sacrosanct. America had dissolved that boundary through the simple expedient of mass production. 20,000 LCVPs, each one expendable, each one replaceable, each one carrying the promise that no coastline in the world was unreachable. Behind each boat stood the factories that could build 10 more, the training centers that could prepare 100 more coxswains, the supply system that could deliver fuel and spare parts anywhere. Salt water met sand. The revolution was complete. Fortress mentality, the defensive philosophy that had shaped military thinking for centuries, was obsolete. Any beach could become a door, given sufficient boats and the industrial capacity to replace them as fast as the enemy could sink them. We end where we began, in the sound of a hinge under stress, the mechanical squeal of a ramp dropping under fire, that smallest sound in a war-sized orchestra, barely audible above engine noise and gunfire, and the splash of men hitting water. But it was the note that changed everything, the simple mechanical noise that announced the arrival of the future. In the end, victory sounded like precision engineering mass-produced and delivered on schedule. It sounded like a promise kept, a door opened, an appointment honored despite all opposition. It sounded, most of all, like the quiet confidence of a system that knew it could return tomorrow with more boats, more men, more of everything necessary to keep that promise alive. The hinge that turned seawater into hallways, the ramp that converted coastlines into addresses, the smallest moving part in the largest undertaking of the industrial age, opening and closing exactly on time, exactly as designed, exactly when 36 men needed it most.